make some progress on this bad boy. Done with the sinusoids, so let's keep going. Use the angle, sum, or difference formula, we'll be giving you those, to simplify the given expression and find its exact value. There's that word again, exact value. We saw that up there. That does not mean type it in your calculator and give us a decimal. It says use the angle or sum difference formula. So you got to go to your formulas, which I have right here. You'll be getting these in a different form probably. But as you can see, we got cosine, cosine plus sine, sine. Look for it. Cosine, cosine plus sine, sine. So they're saying go from here to there. The first one is u. Second one is v. So we need this. We need cosine of u minus v. So we're going to go stick things where they belong. 71 minus 26, which is cosine, what would that be? 45. Now again, we've done this before, but if we spun our spinner 45 degrees, you look at it, that's a 1, that's a 1, that's the square root of 2. So cosine would be adjacent over hypotenuse, which is 1 over the square root of 2. If we get that out of there, get the square root of 2 over 2. And there's my answer. Similar problem, but we got to use these identities here. We got sine, cosine plus cosine, sine. Where is it? Sine, cosine plus cosine, sine. So it's saying use this. So sine of u plus v. So there's sine of u plus v. That's what we got to fill in. First one's always u, second one's v. Add those together, and they conveniently gets 60. 49 plus 11 is 60. So take a look at this situation. We spin our spinner 60. That's 30, 90. That's our 1. That's our square root of 3. That's our 2. What's sine? Opposite over hypotenuse. That'd be a square root of 3 over 2. Now, next section says use the double angle formulas, and here's the double angle formulas. Again, you probably won't get this exact same formula sheet, but you get the idea. So I will fold it right here, and so here we go. So it's kind of similar. They're giving you the finished product basically, cosine squared minus sine squared. Here it is, cosine squared minus sine squared. So they really want us to find cosine of double the angle. So the angle is 8x in both cases. So we just simply need to go from here that way and double the angle. So it's 16x. Notice it says simplify. It doesn't say find the exact value because we don't know what x is. So you're done. Same thing here. I'm assuming, I don't know what this, okay. So right here, I think this is supposed to be part B. And you can see 2 sine cosine. I'm not looking at this, and I'm not looking at this. Looking for the generic set, the way it's set. 2 sine cosine. Here it is, 2 sine cosine. So what's u? U is 4x. We got to double that and make it sine. So if we double this, we get 8x, and then it's just sine of 8x. All right. Now we're going to get into some more mathy math. So number 11. So we got secant of 270. Well, what we have to remember is that's a positive spin. So we take our spinner, we spin it 270. Now what I taught was stop just shy of it. To create your imaginary triangle on these quadrantals, go back to the x-axis and take a little look. My adjacent side is 0. My spinner we'll just call 1. And that would end up being my opposite side, which technically would be a negative 1. Now, secant, exact value means find the fraction in this situation. What's the reciprocal of secant? The reciprocal of secant is cosine. So if we find cosine of 270 and flip it, then we'll have our answer. So cosine is adjacent over hypotenuse. In this case, it's 0 over 1. And if we say, well, wait a minute, we got to flip this, that's 1 over 0, which is undefined. All right, cosine of negative 603 degrees. Well, let's go down to B. We'll just stay in order here. I got a little room. So this right here, remember, it's 2 times 180 over 3. Or it's just pi over 3, which is 60, times 2, which is 120. But here, we would reduce 60. Regardless of how you get it, you got to get 120. So this is cosecant of 120 degrees. That's telling us how far to spin our spinner. Again, not a lot of space here, but so we're going to go 90 plus 30 and be very accurate with your drawing. Because if this is 90 and this is 30, that leaves us with a reference angle of 60, which means this is the square root of 3, this is negative 1, because that's 30 up there, and this is 2. Okay, let me focus here. See if that helps a little. So, what is the reciprocal of cosecant? It's sine. So if we find sine of 120 degrees and just flip it, then we're on a good road. Sine is opposite over hypotenuse, but we need to flip this to get cosecant. So that would be 2 over the square root of 3. We better get that square root of 3 out of there. 2 square root of 3 over 3. And there we go. I'm going to pause this for just a second. Okay, so letter C's got a little something going on here. I'm really questioning if that is supposed to be a 3. I think that might be a little typo, because I'll show you why. We should end up, after spinning our spinner, getting 35, 45, or 60 degree reference angles. But if we took negative 603, which by the way, that means spin your spinner down. So we have our spinner, we got to go down 360, so it goes all the way around. But then we got to go 243 more degrees. That's kind of confusing. So I'm going to go ahead and just assume this is a typo and say it's supposed to be negative 600. So that would be negative 360 plus another negative 240. So I went around 360. Here's another 180 plus 60 would take me right up here. There's my 60, so this is the square root of 3, 2, negative 1. Cosine is adjacent over hypotenuse, so that'd be negative 1/2. Pretty sure that's a typo. All right, let's go on to this last one. Let me pause this just a minute. All right, need a calculator for this one. So, a couple ways of doing this. We could go 17 times 180 divided by 3, but what I like to do is just look at this and say pi over 3 is 60. 60 times 17. So 60 times 17. We can see this is a big number. So it's sine of negative 1,020. See, we got to play around with this for a little bit. So let me get this piece of paper out for us. And let's talk about it. Let's take out chunks of 360. So negative 360 and negative 360 is negative 720. Now, if we just say, all right, let's spin our spinner twice around. We got to go down. So that's 1, 2. It's like we've gone nowhere. So what's the difference between these two? It's 300. So I got to keep going 300. So if I just kept going, there's 270 plus another 30. And then I stop. Keep track of those details, because if that's 30, this is the one I'm really interested, that's 60. So I draw it back to the x-axis. This is my square root of 3. This is 1. That's my 30, and this is 2. What is sine of this situation? Opposite over hypotenuse. So it's the square root of 3 over 2. There we go. All right, so number 12. The old simplifying ones. Seems like you either love these or you hate these. So my helpful hint is 99.9% of the time you don't change sine and you don't change cosine. If you keep that in mind, these work out a lot better. So what I'm going to concentrate on is the numerator here and see if I can find that. Now, a lot of times they only give you this, sine squared plus cosine squared equals 1. But if you move this over, you move that over, you get 2 more basically built off this original one. But I can see that 1 minus cosine squared is equal to sine squared. So I'm going to replace this with sine squared x over cosine squared x, and I'm done. Or are you? Because if you look right here, sine squared, remember theta and x mean the same thing. That equals tangent squared. So we got tangent squared x, or theta, however you want to look at it. Okay, let's go on to letter B. So, if we take a look, remember this rule, 99.9% of the time, don't mess with this, don't mess with this. That is drawing your attention to this on this problem. So we're just going to follow that rule just to get started. We're going to say, hey, what is secant? Well, secant is right here. It's 1 over cosine. So we're going to replace that with what it is, 1 over cosine minus cosine. I'm simply following this rule. Now I'm going to say, okay, let's go ahead and distribute, because I can see some things are going to cancel. So these cancel on this one, so I just get 1. But then when this hits this, I get minus cosine squared x. And you think, hey, I think I'm done. But you're not. 1 minus cosine squared equals sine squared. And then you're done with that one. All right, there's the bell, which means I got students coming in. Got to pause this for a bit. Record. Okay, we're going to work on letter C. Remember our 99.9% rule? Don't mess with this, which is targeting this. So if we look at our little sheet, we know that secant is 1 over cosine. We should just know that the reciprocal of secant is cosine. But we're going to rewrite it as sine of theta times 1 over cosine of theta. And nothing reduces, can't cross reduce or anything, so this just turns into sine of theta all over cosine of theta. And the danger is just to leave it and think you're all good. But the problem is sine over cosine equals tangent. So we're not done until we actually pick this. If this is a multiple choice problem, I bet you that's an option, but that's not done. So let's go to letter D. So we just talked about secant is 1 over cosine, so let's go ahead and steal that. And what's the reciprocal of cosecant? Well, that's sine, so that's the same thing as 1 over sine. If you don't believe it, check your cosecant right here. And so now we just have a fraction divided by a fraction, so we take the bottom one, flip it, and multiply. Can't cross reduce, so we get sine over cosine again, which, same thing as here, is going to equal tangent. All right, so number 13. I'm going to pause the video for a second. Number 13a, solve each of the triangles. Notice 41, 64, I'm going to add those right away and get 105. Subtract that from 180 and I get 75. So I just do that by habit. Most of the time it's helpful, but some of the times it's useless. But in this case, it's helpful. So we've got a list of our law of cosine, law of sine, and remember this one is the easy one. So if we can get away with using the law of sine, we should. So what I'm going to do is I'm going to take a look at this. I've got this angle now, and I've got that side. So I'm leaning this way. Sine of C sine of angle C all over side C. So sine of angle C all over side C. And now I can just pick. I'm going to go with B. So sine of 41 degrees all over, and if that's big B, the opposite side is little b, so that's little b. All right, so once again, we're about to find sine of 75 degrees. So in this class, you got to make sure you're highlighting degree, and we are. So sine of 75 is 0.965 0.665 all over 28 equals, now we're going to go sine of 41, 0.656 all over side B. Now we could reduce this, but what I'm going to do is if fractions are equal, so are their cross products. We're going to use that rule. Just seems to make sense. 28 times this, I'm going to go times 28. 18 point, we'll just round it to 37. And I'm going to divide by 0.965, divide by 0.965, enter. 19.03, so I'm just going to assume that they kind of want us to round to this whole number, so B is 19. And just for review purposes, I got to ask this question, can I go A squared plus B squared equals C squared? And the answer is no to the Pythagorean theorem. Every now and then a student tries this. You can't use this unless you have a 90-degree angle, and we don't. But now we do have a situation where we've got, we can just use this again in the law of sine. So I'm going to go sine of angle A all over side A, and I can just use this one again, and I'm just going to put that stuff where it belongs, 0.965 over 28. So sine of 64 is 0.898. I got to multiply that by 28. So I get 25.1, we'll round a little bit, equals cross multiply 0.965a. Divide by that. Divide by that. 0.965. 26.07, we'll just say approximately 26. So now we know this is 26, and there's everything solved. Okay, last problem for this video. So again, that problem we had two angles, so we could find the third. We don't have that luxury over here. But we do have this angle, this side. We have this side. We can easily find that angle using the law of sine. So sine of angle A all over side A equals sine of 62 all over side B. Now, figure out what sine of 62 is. So sine of 62, 0.882. But we're going to multiply that straight across by the 25. 22.07. I'm going to cross multiply this way, and I get 28 sine of A. Got to divide by 28, divide by 28. Something we haven't talked about in a while is coming up. So I got to divide that by 28, 0.788. So 0.788 equals sine of angle A. How do we go from this to finding out what the angle is? Well, now we got to go inverse sine, 0.788, and this is telling our calculator, if sine equals this, please tell me what angle A is. So here we go, second sine, 0.788, we get 51.99, pretty safe to assume they want us to say that angle A is 52. So I'm going to write that right in here, and use a little common sense. This is 114. If we subtract that from 180, we got 66 degrees right up here. So, using the law of sine, we can find side C. We're going to use angle C, side C, so here it comes. So sine of angle C, 66 all over side C. Again, you can't use Pythagorean theorem, can't. And I'll just use this one again. So 0.882 over 28. So sine of 66, 0.913 times 28. So that's, make sure I'm still on the screen here, 25.58, we'll round a little bit there, equals, cross multiply this way, 0.882c. So we got to divide by 0.882, gone, 0.882. 29 almost on the nose, so C is 29. So we got all our parts there. And that ends this video. If you like the video, like and subscribe. If you don't like it, like and subscribe. Thank you.